we have this beautiful integral that we want to solve. So we have integral from 0 to 1 of the fractional power function of 1 over x dx. Okay, so if you're new to this channel, don't forget to subscribe, don't forget to like, don't forget to comment, and don't forget to share. Okay guys, now let's dive into the solution. Now, the first thing I'm going to do, I'm going to explain vividly what the fractional part function is all about. So your fractional part function, okay, so fractional part function of x is equal to x minus the floor function of x. So you can check my videos on floor function of x. I've made like 3 to 4 videos on floor function of x. So you can check my videos on that. So I'm gonna send the the link also in the description so that you guys can actually watch the videos or the lectures on the floor function of x. Alright, now what is the fractional part function is saying? When you ask to find the fractional part of a number, it means you are taking the decimal part only. You understand? You are taking the decimal part only, but the floor function, if you are asked to find the floor function of a particular number, you are asked to take the integer, not the decimal. Okay, that's the difference between the fractional part function and then the floor function. The fractional part function and the floor function, that's the difference between them. Alright, and then the quantity given to us here is fractional part function of 1 over x. So this will be equal to 1 over x minus the floor function of 1 over x. Alright, so I'd like to show the visualization of this quantity on the graph. So if you plot the graph will look exactly like this. So the quantity given to you is the floor, what's it called? Fractional part of 1 over x. So the graph will look like this. Okay, so this is how the graph will look like. So this is y is equal to fractional part function of 1 over x. So that's what we're going to have with the graph. That's how it's going to look like. So at some point, the graph, the point they oscillates at some point. That's how you have this. And then at some point, your floor function here it remains constant at some point. You understand? So the floor function remains constant at some point. Okay, now here's your floor function briefly. So if floor function of x is equal to n, so this implies that n is less than or equal to x, then less than n plus 1. So take note of that. Okay, so n is less than or equal to x, then less than n plus 1. Alright, that's cool. So don't forget, I said at some point here, the floor function the floor function remain constant. So what we are going to do now, for us to be able to solve this problem, so let me partition the board. So you can say that suppose the floor function of 1 over x is equal to n. Do you understand? So you suppose that floor function of 1 over x is equal to n. So then if floor function of 1 over x is equal to n, so this will imply that n is what? Less than or equal to 1 over x, then less than what? N plus 1. Then we take the reciprocal, so we're going to have 1 over n plus 1, okay? So it's less than or equal to x, then less than n. So that shows that x belongs to this interval. We have 1 over n plus 1, and so open interval, the closed interval. Good. Alright, so that is what we have. Then we can now rewrite this particular function right here. So I can say that the fractional part function of x, of 1 over x, will be equal to 1 over x minus n, since we suppose that the floor function of 1 over x is equal to n. So then we can now write this integral entirely. So we rewrite the integral, so we're going to have the summation of n, okay, from 1 to infinity, then of integral from 0, is it 0? No. From what? 1 over n plus 1 to what? To 1 over n, sorry. We are taking reciprocal. So to 1 over n. To 1 over n. That's cool. Then instead of you writing the fractional part of 1 over x here, so we'll have 1 over x minus n dx. That's cool. So now let's move on. So next thing we are going to do is to integrate this function, and that's very easy to integrate. So the function here is, we want to integrate 1 over x minus n dx. So this will be equal to integral of 1 over x dx, then minus integral of n dx. So this will be equal to, if you integrate 1 over x dx, that's going to give you natural log of x. Then if you integrate n dx, that's going to give you n x. So we're going to write this as summation of n from 1 to infinity. So then you apply the limits. So we have natural log of x minus nx. Then if you apply the limits, we have 1 over n plus 1 to 1 over n. That's cool. So if you apply the limit here, so we're going to have summation of n from 1 to infinity of natural log of x. X is now 1 over n. Then minus n into brackets 1 over x. Okay. Then minus, if you apply 1 over n plus 1 as your x, so that will be natural log of 1 over n plus 1, then minus n multiplied by 1 over n plus 1. That's cool. So let's complete this. So we're going to have summation of n from 1 to infinity, okay, of natural log of 1 over n, then minus, so n, and this n we cancel out, we have 1, okay, we have natural log of 1 over n minus 1, okay, then minus natural log of 1 over n plus 1, then minus n over n plus 1. That's good. So we can open the bracket right here. So we open the brackets, so we're going to have sum of n from 1 to infinity of natural log of 1 over n minus 1, okay, then minus natural log of 1 over n plus 1, okay, plus n over n plus 1. Then next thing you are going to do now is to collect the like terms. So let's clean this part. So we collect the like terms, we are going to have, so this and this will come together, and this will come together. So we're going to have sum of n from 1 to infinity of natural log of 1 over n, okay, then minus natural log of 1 over n plus 1. That's cool. Then minus 1 plus n over n plus 1. So then if you apply the law of logarithm, so what does the law of logarithm says? Okay, so if you have natural log of a minus natural log of b, so this means natural log of e over b. Just forget that. So we can apply that here. So we're going to have sum of n from 1 to infinity of natural log of 1 over n, okay, divided by 1 over n plus 1, then minus 1 plus. And also remember n over n plus 1 is the same thing as 1 minus 1 over n plus 1. So take note of that. So instead of rewriting n over n plus 1 here, so we're going to write 1 minus 1 over n plus 1. So we have sum of n from 1 to infinity, so of natural log of, so 1 over n divided by 1 over n plus 1, that will give us n plus 1 over n, and minus 1 plus 1 will give us 0, then minus 1 over n plus 1. That's cool. Alright, so that is the sum we have. So let me clean this part. So therefore, integral from 0 to 1 of fractional part function of 1 over x dx is equal to this beautiful summation, which is sum of n from 1 to infinity of natural log of n plus 1 over n minus 1 over n plus 1. Alright, I've uploaded this video, so if you check my video, I'm going to send you the link in the description so that you can watch the solution to this beautiful summation. So what I'm going to write now is just to write the solution, the answer or the results. Okay, I already solved it completely in my video, so make sure you watch it so that you don't miss how we got the answer. Okay, it's very important. So this will be equal to 1 minus the Maclaurin constant. Euler Maclaurin constant. Are we together now? So if we solve the summation, this is what you're going to have. You understand? So make sure you watch the video. So therefore, hence, this beautiful integral from 0 to 1 of the fractional part function of 1 over x dx is equal to 1 minus the famous Euler Maclaurin constant. Alright, so that's that about that. So if you like this kind of video, don't forget to subscribe to my channel Don't forget to like my videos, comment, and also share. And click the notification button so that anytime I upload video, you will be the first to watch. Alright guys, thanks for watching. See you next time. Goodbye.